You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
And if you've got a question for the Naked Scientist, remember, it gets very busy. Give us a call and have your best shot at asking Chris whatever it is that you'd like to ask him on 011 883 0702 and in Cape Town on 021 446 0567. Good morning, Chris.
Eusebius, good morning.
I believe you're down under somewhere. Are you in Australia?
Yeah, well, for me it's evening. Yeah, I'm in Sydney in Australia, and
right.
It's not quite flooding weather, but it's certainly raining very hard here as well. So it seems that wherever I go, I sort of deliver rain. Bit of a shame, because I was hoping to catch up on my vitamin D, but that's not going to happen, sadly, on this trip.
I feel a little better than last week with all this travelling. I can't help.
I'm recovered now. I've given the virus to my wife, who emailed me yesterday and said, I'm feeling very, very unwell. So I think I'm going to have to buy her a very big present at the airport to apologise.
Chris, I'm fascinated. There's a story we'll share with listeners first up before we take their calls. I mean, we know that data, is hectic because there's just so much of it, and that hard drives may not be capable of keeping up. But of course, that's where clever scientists come in.
Yep. And a stat I read the other day is that by 2020, the world will be endeavouring to store something like 44 trillion gigabytes of data. That's a lot of data. Every year we're churning out about an exabyte, and our rate of data production, in other words, everything from pictures of cats on the internet through to what you're pinging around on email to your medical records and so on, this is rising exponentially. And in the last couple of years alone, we have generated more data as a human civilization than we have in all of the thousands of years previously. So this begs the question, well, what are we going to do with all this data? How do we store it? Because at the rate of growth, present technologies just can't cope. And at the same time, how do we make sure that that data remains readable into the future? Because if you think, you can go to the pyramids in Egypt and you can read the hieroglyphs there, and they're still comprehensible thousands of years after someone wrote them. You can look at the Rosetta Stone. You can still read it. You can look at the Doomsday Book written 1,000 years ago in Britain. It's still legible. But if you have a Betamax or a VHS video, you can't play those tapes anymore because the machines don't exist, or the tapes have degraded. So how do we make sure this doesn't happen? So scientists are turning to DNA, the stuff that actually is the recipe book inside the majority of our cells in our body, as one solution. And this is not necessarily a brand new idea, because scientists have been trying to store data in DNA for a number of years now. But there's a paper in the journal Science this week by a researcher at Columbia University, Yaniv Ehrlich, and he's come up with quite a clever way of encoding information in DNA. And to prove his point, he stores a movie, a small operating system, an Amazon gift voucher, and a bit of malware, just for good measure, all as a DNA code, as a piece of DNA in a little tube. And he can then read the DNA code by DNA sequencing techniques and recover the data back to being a computer program that works, a bit of malware that works, an Amazon gift voucher that works, and everything else. And it's not fast, because obviously it takes time to do all those things, and it's not cheap. It costs $3,500 per megabyte stored. But think about it, DNA lasts for thousands of years. Very robust, very resilient. We can go to fossils that are 500,000 years old and get DNA out of them and read it. So this may well be one clever way to pack enormous amounts of data, far more than we can pack into anything else, because DNA is so compact and so small. And this may be the solution for long-term data storage in the future.
Absolutely fascinating. Got a question for Chris? Give us a call if you are in Cape Town on 021 446 0567. And the Naked Scientist will do his best to answer your question. And, of course, if you are in Johannesburg, you can give us a call on 011 883 0702. You can also SMS your question if you'd like to do that alternatively on 31702 or 31567. And you're more than welcome to tweet us a question. I'll put it to him at Eusebius, at Radio 702, or at Cape Talk. Pam, good morning.
Hi, Eusebius. How are you?
Very good. Thank you, Pam. What is your question?
Oh, I just wanted to find out, is there like some kind of correlation between pregnancy and memory? What happened is that when I had my baby last year in January, but I'm forgetful ever since then. So I was just wondering.
Okay.
Hello, Pam. What's your baby called?
Sorry?
What's the name of your baby?
The name is Kosin Pile.
Oh, phew, I thought you forgot that too.
No, I can't hear you very well. Sorry.
I thought she might say I've forgotten. Pam, this is a phenomenon called baby brain, and it's been around for a long time. People are saying that when people get pregnant and when people have children, they suffer from a loss of memory and possibly even a brain shrinkage afterwards. There is evidence that the brain remodels in a lady when she has had a baby. People have done brain scans to show that, but there is no evidence whatsoever that people perform psychologically any worse afterwards or drive any worse, because that's been another accusation that's been levelled. There's no evidence for that. But what you can say is that when people have a baby, then a number of changes happen in your life. Your sleep is very often disturbed. You're very tired all the time. And some people also suffer from the condition called baby blues or postpartum psychosis in severe cases. And this is a minor and in some cases major depressive condition which can follow childbirth, which can be a cause of or can be caused by disturbed sleep and also by the hormone changes that accompany pregnancy and birth. And depression in and of itself can have an effect on memory. So it's possible that if you're suffering from poor sleep, from being tired all the time, or from one of those other conditions, this may have a short-term effect on memory. But as children grow up and as we adapt to looking after them and we become better parents, we tend to find that these things go away. And there's no evidence for a long-term deficit, you'll be pleased to hear.
Thank you, Pam. Dumasani, hello.
Hi, how are you, Eusebius?
Very good, thanks.
Fine. I just want to find out what connects us as human beings from the rat species in terms of scientifically, because when something is done in terms of new inventions or like medical stuff, what connects us between rats and humans? What is it that connects us? Well, because if it's successful with a rat, then they implement it to human beings.
Chris?
Yeah. Well, this is an excellent point. And the reason that we test things on rats is because rats breed very quickly. They're simple. They're cheap to keep. But they are mammals. And we are mammals. And we share a large amount of our DNA in common with a rat. The way our bodies work, very, very similar. The way our immune system works, very, very similar. So if you're trying to design a treatment or you're trying to understand how a disease occurs, you can test it quickly and cheaply and safely in a rat, and this will enable you to highlight a number of possible avenues that either will or won't work in a human. But humans are not rats. There are important distinctions, and so we still have to test some things on humans, and the rules are that you can't make a drug and put it into a person until it's been through animals. That's the law, but then you've got to do safe clinical trials as well. So the simple answer to your question is that because rats are very, very similar to humans, genetically and physiologically, the way their body works, we regard them as a good test vehicle to try things out first before we go to the next step and try things on humans. And this means we can avoid doing damage to humans by testing things that would be unsafe from the get-go.
Don't tell that to Peter. They might come and protest outside your lab. Tebza wants to know on Twitter, please ask the doctor what causes stomach stitches and what can one do to prevent them while you are running?
Okay, well, just to define what is a stitch is a pain you have in your abdomen when you're running, and it's usually brought on by exercise, or especially if you're unfit. Now, what happens when you have a stitch is that it's all to do with the disconnect between breathing and your stepping. So let me just explain. The liver, which is your biggest internal organ, can weigh 1 kilo or more in a big person, sits at the upper right side of your abdomen. It sits under your diaphragm. When you breathe in, you're pushing your diaphragm down, and this decreases the pressure inside your chest, so air enters your lungs. This also pushes the liver down. Now, when you breathe out, your diaphragm comes up and increases the pressure in your chest and pushes air out. But because the liver is heavy, when you're running, you're, of course, going up and down, because as you run, you bob up and down. So as you put a foot forward, if you're putting your weight forward, your liver is travelling downwards. If you therefore breathe out at the same time as your liver is trying to go downwards, the diaphragm is going up and the liver is going down, and this stretches the ligaments that support the liver, and that's painful. So one way to deal with a common cause of stitch, which is stretching those ligaments, is to try to time your breathing with your stepping so that your liver will be going down at the same time as your diaphragm is going down, and this will minimise the stretch on the ligament and it will minimise the discomfort.
17 minutes after 10, let's take a quick break. Any calls that you have for the Naked Scientist? Questions, you can call us. The lines are now open.
702 and Cape Talk.
The Naked Scientist.
20 minutes after 10, it is the Naked Scientist. Let's put more calls on. Freedom, hello.
Hi, good morning. Thank you for taking my call. My question to ask Dr. Chris is that if you are a gym member, let's say you are a young gentleman, you want to push up your muscles, to gain the muscles, and then you eat these supplements like the protein, iron, does it have a long side effect? And then what about if, let's say, you are old, you are sick person,
yes,
now you are taking the same thing like fresh beans and all those things. Does they really help you, or they just sustain for that little while?
That's such a good question. Geez, I've been chowing the whey protein. Are they bad for you in the long run, Chris?
Well, the bottom line is that, and there was actually a press release from the British Heart Foundation this week on a paper showing that just not doing any exercise is far worse for you than a whole raft of other bad for you things. And so, in fact, if you're not doing any exercise and you become obese, you actually have to get really quite obese before the health effects of being obese are as bad for you as not doing any exercise. So the evidence is that regardless of how old you are, exercise is always beneficial within reason. And so you should exercise sensibly, and there's no reason why, as long as you taking these supplements, if you take sensible things and you take them for a reason, so you're meeting the metabolic requirements of your body, you're going to do yourself no harm, and the exercise is definitely going to do you some good. If you take too many of these things, then you may gain weight. You may also find that they contain other things that are not terribly good for you, and they're certainly going to be bad for your wallet because they're very expensive. So I would say eat a healthy diet, but definitely do the exercise, because you actually, there's no pill which you could possibly take which is as good for you as just doing modest exercise in terms of your reduction in cardiac and stroke and blood pressure risk and diabetes risk.
Gugu, hello.
Hi, yes it is.
Thanks for calling in. What is your question for Dr. Chris?
Yes. Good day. My question is, what is the correlation between the lines on our hands and paternity? Because there was a guy in the program, Udadako, the other day, when he disputed the paternity based on the lines on the hands, and the results were negative. So was that just a sheer coincidence, or there is a correlation with paternity and the lines on our hands?
The only coincidence here is how much money these people make for peddling you rubbish. There's no evidence that the lines on your hand, which are purely a developmental artifact, so as your body grows, it follows instructions in the cells that are forming each bit of your body, and you get these lines which are pretty random from one person to the next, but they're there just because of the way the body forms. There's no correlation between those lines and any other aspect of how long you're going to live, whether you'll fall in love with somebody, whether you'll have lots of children or no children. There's no evidence for any of that. It's all just snake oil. So save your money, and the best thing to do is to have a healthy lifestyle if you want to have lots of children. And you obviously need to have sex as well, and that means you need a partner. But in terms of actually how many children you'll have, that's largely determined by the fitness and health of the parents.
Thanks, Gugu. Thanks for that question. Here's one from Twitter again, Chris. Actually, this is a lovely one. How does altitude affect sportsmen during the play? This person wants to know what actually happens to the body, because we keep talking about differences, playing at altitude or playing down in Cape Town. What happens to the body?
Well, people who are professional athletes will often train at altitude. And the reason for doing that is that the body's response to altitude is to increase the ability of the tissues to pick up oxygen from the blood And also the blood increases its ability to pick up oxygen from the lungs and to carry oxygen. The reason for doing this is that as you go up in altitude, although the percentage of the air that is oxygen remains the same, about 21%, the density of the air goes down. In other words, there are far fewer molecules in every cubic metre of air at altitude than there are at ground level, because the air is expanded at altitude. And therefore, although the percentage of molecules that are oxygen remains the same, the number of oxygen molecules in total is much lower. Therefore, it's much harder to drive oxygen into the bloodstream at altitude. Therefore, the tissues find it much harder to pull oxygen out of the blood at altitude. So if you train at altitude and force your body to adapt in the same way that people who live at high altitude, people who live in Joburg are subjected to lower oxygen levels than people who live in Cape Town, for example, doing that forces your body to adapt. And this means that when you play at a lower altitude, your body has already got a much better ability to carry oxygen around the bloodstream, get it out of the air and get it into your tissues. And this gives you a competitive advantage because you're delivering much more oxygen to your muscles. And the more oxygen you can get into your muscles, the longer they're going to work aerobically. In other words, they're burning sugar using oxygen. And this means they're less likely to get tired because of anaerobic respiration, which is when you get sore muscles because they're working with an oxygen debt. And that means you're going to perform better and faster and for longer.
Nswaki, good morning. Thank you for calling in and for holding on.
Morning, Eusebius. Morning, Chris.
Morning.
Morning. I have a 4-year-old, and every time when he's about to fall asleep, the body starts to twitch. You know, the arms and the legs and the side of the neck. But then he has gone through the EGG and the MRI, and I can't remember some of the tests. But it's not like the brain was, nothing was picked up on the brain. They're saying the brain is perfectly normal and everything. So besides the brain, what else could be the cause, you know, to the twitching muscles and all?
Yeah, obviously I haven't seen your son, and I'm very relieved to hear that everything proved normal in the tests. But what I can say is that actually this is quite a common phenomenon, and most people have this happen to them, albeit in a limited way, fairly frequently, and it's called a hypnic jerk. And as you go to sleep, your brain engages various mechanisms that paralyze your muscles. And the reason for this is that when you drop off to sleep, you don't want to be acting out your dreams, because if you're dreaming you're running away from someone, you don't want to be leaping out of bed and then jumping out the window or something. So there's a part of your nervous system which is called the subcerulear region, which is in your brain stem, and this engages or switches on when you go to sleep, and it gates or turns off the supply of motor information, in other words, movement information, going out of your brain down towards the spinal cord where it would control muscles. And in this way, your body paralyzes itself. And it may well be that this system, because your son is young and he's growing and his nervous system is developing, it may be that this is perfectly normal wiring of the nervous system. And it's just this hypnic process. As he goes to sleep, he's just getting these muscle twitches and jerks. And in some people, they're a bit more pronounced than others. So I hope that's what it is. But obviously, it is important that he gets thoroughly investigated to make sure.
Mm-hmm. Nswaki, all the best. Thanks for that question. Michael, thank you so much for calling.
Hi, guys. I would like to find out what happens to the body when one is in an accident. Because the reason I'm asking, okay, the shoe will come off. The reason I'm asking, I once witnessed a police on a motorbike. He fell, and as he was sliding, his long boot came off his foot. I just didn't understand the phenomenon. Then I watch TV. Sometimes I see this program. People in an accident, sometimes shoes will come immediately off. What happens? What causes that?
Well, I think you've got to think about what's happening when a person is moving on a vehicle. Although the person relative to the vehicle isn't moving, relative to the ground, the person is moving very fast. And that means that the clothes they're wearing and the shoes they're wearing are also moving very fast, and they have momentum. Now, if the person stops suddenly, for instance, if they're on a motorbike and they go over the handlebars, then they will be slowed down by the handlebars because they'll be holding on, but their legs will go whipping over the top, and their boots will still have lots of kinetic energy, momentum, and they will come flying off, potentially, and go whizzing off up the road in the direction that the person already had momentum in. So I suspect that part of the phenomenon is that's what's going on. The person, when they come bowling over the handlebars of their motorbike, they literally wheel over and flick their boots like a welly throwing contest, and their boots come off.
Okay, thank you.
Thanks, Michael. Thank you, Chris. Thanks so much. Always great having you on the show, and we'll do it again next week.
Okay, thanks very much, Eusebius. Thanks, everyone, and see you soon.
Cheers. That was this week's edition of The Naked Scientist.